Chemistry, this is the first in a series of lessons on the subject of empirical formula. So an empirical formula is the lowest ratio of atoms in the formula of a chemical compound. The molecular formula is the formula of the actual compound, molecule, or formula unit. So here are some examples. If you have a molecular formula of C2H4, we've seen that molecule in class. If you reduced it to its lowest ratio, there's 1 carbon for every 2 hydrogens. That's the empirical formula. If you have BH6, you can reduce that down to BH3, just like reducing a fraction or factoring out the number. This is glucose, C6H12O6, becomes CH2O. And H2O water, well, that is the empirical formula. That is the lowest ratio of hydrogens to oxygens in water. So what is an empirical formula used for? An empirical formula is an intermediate middle step that takes laboratory measurements and uses these measurements to determine the molecular formula of a compound. That is the actual formula of the compound. So you take laboratory measurements, and we always get things in grams usually in a laboratory. We work in the world of grams, but then we need to convert it to moles. So once we have it in moles, we come up with an empirical formula. If we then know the molar mass of the substance, we can figure out the actual molecular formula of the compound. Okay, so let's take an example here. A decomposition reaction of 1.443 grams of selenium and 6.472 grams of bromine. What is the empirical formula of the SeBr compound that was decomposed? So we get in the lab, we come up with that we have 1.443 grams selenium, 6.472 grams of bromine. That's what we find in the lab. Now we want to find out what the empirical formula of that compound is. Okay, so there's a decomposition reaction. So compute the moles of selenium and bromine using the molar mass. So go to your periodic table, find the molar mass of selenium. 1 mole is 78.96 grams. That's straight off the periodic table. And when you do the stoichiometry on that, you get that that's 0.018 moles of selenium. Do the same thing for bromine. Get the molar mass of bromine off the periodic table. Do the conversion. Grams bromine cancels with grams of bromine, and you end up with moles of bromine, 0.081 moles of bromine. So grams is what we measure in the lab. We use the molar mass translator to make the conversion, and we end up with number of moles. That's what the chemical equations or chemical formulas understand. They're counting numbers of particles. Okay, so create a ratio of the number of moles for each element you obtain. Place the smallest number of moles that you computed on the bottom of all ratios. Okay, so there we have the ratio for bromine. Bromine was 0.081 moles, and selenium, which is the smaller of the two, you put on the bottom in the denominator. Now, for selenium, you had 0.018, and you put that on the bottom. So divide the top number by the bottom number. So you get 4.5 for bromine, and you get 1 for selenium. The smaller of the two ratios, smaller number of the two ratios is always going to end up to be 1. So we multiply by whole numbers 2, 3, 4 until you have a whole number for the subscript, because you're not allowed to have 4.5 as a subscript. So we're going to multiply 4.5 by 2, and we can stop right there. We don't have to go any further. We got a whole number, 9. But you also have to keep that same ratio with selenium, so you have to multiply that by 2, and so you get 2 for selenium. So that means you place these numbers as subscripts, and you end up with the empirical formula of Se2Br9. Now keep in mind that's an empirical formula. The formula of the actual selenium bromide molecule could be Se4Br18 or Se6Br27. In other words, any multiple of those two numbers. So that we're not going to deal with until the later lesson. All right, and that takes care of this lesson on empirical formula. This will get you started, and we'll spend a few days on this so that hopefully it becomes clear by the end of those lessons.